All right. So yeah, today is our talk is data streaming on Kubernetes with Apache Kafka and Strimzi, and of course I said we have Jakob Schultz, Senior Principal Software Engineer at Red Hat. We met at KubeCon back DoK Day in Paris last year. Um, so I've invited him to give us a talk. So yeah, I want to give a special thank you to our newest Platinum community sponsor, EDB. So thank you for your contributions. EDB allows us to do these live streams and get people together. So thanks for that. I wanted to let you know that you can watch all of the talks from DoK Day at KubeCon North America. They're available now on YouTube. So if you use that QR code there, it'll take you to the playlist and you can watch all those talks. There's a lot of great talks that we had this year. So definitely check that out. And then of course, KubeCon EU in London is coming up pretty shortly in a few months. The CFP was, of course, closed, but the schedule should be announced this month pretty soon, so on January 23rd. So if you want to learn more information, actually, and if you want to register to attend, you should go ahead and do that. You scan the QR code on the right. That'll take you to the DoK Day page. But of course, from there, you can register for KubeCon. And just a note, if you want to attend the co-located events, which DoK Day is one of those, you have to get an all-access pass. So there is no just co-located event pass. It's the all access pass that gets you access to those events. But there's lots of other great events as well on that day. I also wanted to highlight we've been pushing this. This is a project, a community project that we did last year, and it's a new year. So if you want to learn some new skills and you're just getting started on your DoK journey, you should check this out. It's our Get Started guide. And if you're a pro, if you're at Data on Kubernetes, we are always accepting contributions. So this is on GitHub. If you see an area where we could use more information, feel free to add that and submit a pull request, and we'll get that added. But it's just a great way to get people started. We think it's a little bit intimidating, I think, to start running data workloads on Kubernetes. So we have the Get Started guide to help you on your journey. So you should definitely check that out. And thank you to our contributors so far. And then coming up next week for our town hall, we have George Hansaris and Dan McKean from MongoDB, and they're going to be talking about building a multi-cloud, multi-region DBaaS. So you can register for that event on our meetup page. And again, that's next Thursday at 10 a.m. And if you want to get involved in the community, you scan that QR code, it'll take you to our community page. And we're always accepting new sponsors to help us plan new events. So if you're interested in that, check out that QR code or get in touch with me. All right, so we have Jakob Schultz today. He's going to be talking about Strimzi. Just a quick note, if you have questions, feel free to just add them to the chat, and I will pass them along to Jakob. If he sees fit to answer it during the talk, he'll do that. Otherwise, all your questions will get answered at the end of the talk. So without further ado, I'll hand things over to Jakob here, and he can take over.
Thanks a lot for having me here and giving me the opportunity to talk a bit about Strimzi and about Apache Kafka on Kubernetes. As already said, my name is Jakob Scholz. I work at Red Hat as an engineer, and really my main job is working on this project called Strimzi, which is a CNCF Incubating project. It's of course open source under the Apache license 2.0. It's a community, so we welcome all our users and contributors to join our community. And really what we do in Strimzi is we focus on running Apache Kafka on Kubernetes in what we call the Kubernetes native way. For that, we are using the operator pattern, which allows us to kind of extend Kubernetes and provide operators for running and managing Kafka and its various components. And together with that, we have also some additional tools to make it easier to run Kafka on Kubernetes in its various forms. I hope you all heard about Apache Kafka. that it's not completely new to you. It's open source project as well. It's part of the Apache Software Foundation. Originally, it was developed by LinkedIn, but now it's one of the biggest open source communities out there. What I want to clarify right from the beginning is that there's a lot of different products and projects which try to implement the Kafka APIs or do some form of Kafka fork, which has some special features. But in Strimzi, we really just provide the tooling for the Apache Kafka itself. So we do not fork Kafka, we do not implement the protocol. We really just inside of Strimzi, there is the real Apache Kafka project as you can get it from Apache Software Foundation. Kafka is a leading messaging and data streaming platform. There are many different ways how you can kind of define and describe it. One of them is distributed, horizontally scalable, fault-tolerant commit log, which I think is absolutely amazing because it explains very well what it is and how it works, but it's also full of amazing buzzwords. So you sound really smart, even if you don't really understand what half of that means. But the relationship between Kafka and Kubernetes, it's maybe a bit complicated because the Kafka brokers, which are kind of the core part of Apache Kafka, they are not exactly cloud native. Kafka is horizontally scalable. That's one of its main features, but it's not necessarily very elastic. And what that means is that you can, with Kafka, quite easily start a small project with, for example, just 3 Kafka brokers to have the availability and reliability. But then as your project takes off for your company and you get more and more customers, more and more users, you can quite easily scale it up and up to kind of make sure that the Kafka cluster can still handle the load. But it's not very elastic in the term that it doesn't necessarily scale up and down every few minutes to kind of handle some immediate utilization. Another thing about Kafka is that while you can easily run Kafka clusters with many, many brokers, quite usually the brokers are pretty big. So you wouldn't run 100 of small brokers with just a little bit of CPU and 1 or 2 gigs of memory. Instead, you would run a smaller number of brokers with quite a lot of resources. So 10 CPU, 64 gigs of memory, and something like that. So again, that's not maybe the perfect fit for running on Kubernetes, but there are some important reasons why running on Kubernetes makes sense. One of them is that a lot of the applications using Kafka are built on architectures which are very nice fit for cloud native and for Kubernetes. So it's often used as a communication backbone for microservices or services based architectures. And quite often kind of the Kafka cluster sits in the center of a cloud native architecture. So that gives you some value to have all of that in one place. But also, if you look at what's happening around us everywhere in the IT and engineering departments, Kubernetes are becoming more and more the real standard for running things, right? And that means that you ideally want to run everything on there because you have people who know how to run Kubernetes, how to use Kubernetes. And why not run Kafka there as well, even if maybe it's not a 100% perfect fit. And that's what we try to do in Strimzi with the operators pattern, where we try to make it as easy as possible for people who know how to use Kubernetes to use Kafka as well, so that they don't need to learn some Kafka specific tools. They don't need to learn some Kafka commands. We try to give them the way how to use Kafka in the Kubernetes native ways, using the Kubernetes tools, using the Kubernetes resources and things like that. Maybe to introduce a bit more about Kafka for those who are not familiar with it, there are various core capabilities which Kafka has. It's able to handle very high throughput at pretty low latency. I already mentioned the scalability. You can use it as a permanent storage if you want. You can store data and events there for a long time. It, of course, has high availability, and it gives you reliability for the data you store there. And you can kind of take these capabilities and use it in various use cases. You can use it for messaging and integration use cases where, yeah, pretty much you use it to build a central backbone for some application architectures, or you can use it to uh, deliver data from one point to another, for example, using Kafka to deliver logs from applications or metrics or traces is pretty popular. But you can also use it to build event-driven architectures and use things such as event sourcing patterns. Or, of course, these days, it wouldn't be a right talk without mentioning things such as stream processing, machine learning, and AI. And you can, of course, plug those into Kafka as well, and you can have them consume and handle the events from the Kafka clusters. And you can, for example, have some AI models to react to the events, evaluate them, and so on. So in Strimzi, when we talk about Kubernetes native Apache Kafka, or the kind of Strimzi flavor of Apache Kafka, as I said, we are using the operator pattern for that. So that means that we have our own custom resource definitions, which allow us to add custom resources to the Kubernetes APIs. And we use these resources to deploy and manage the Kafka clusters. I will talk later in more detail about the different resources, but you basically create the resource which describes the Kafka cluster, for example, and then the actual operator is an application which has the knowledge which, for example, a human operator would need to run a Kafka cluster, kind of encoded inside in its source code, and then use these custom resources to kind of manage and operate the Kafka cluster. And what we try to do is we try to automate the installation. That's kind of always the first step to deploy a new Kafka cluster. But then we, of course, try to support all the different day 2, day 3 operations to make sure your Kafka cluster is running even after a few months or a few years, that it can be monitored and things like that. We try to make things kind of simple yet configurable. Kafka offers quite a lot, but sometimes it can be a bit challenging, and there's a big difference between some super simple development cluster, or if you just want to try Kafka for the first time, that's usually pretty easy to deploy. But when you have some production environment which has to handle gigabytes of data per second, then yeah, that obviously needs some fine tuning. It needs to have it properly configured to handle the amounts of data. So that's where we try to make sure that you can kind of use it in the both ways, both deploy some simple development or test clusters, but also use Strimzi for the production clusters. Yeah, and we also try to be secure by default. So yeah, we provide various security features, and the internal communication is all secured, and so on. In Strimzi, we support all the different Apache Kafka server components. So right now I will mainly talk about Kafka brokers. That's kind of the central part. Then there's a Kafka Connect, and there's Kafka MirrorMaker 2. You might notice that I didn't mention Zookeeper here. So we, of course, have Zookeeper support up until Strimzi 0.45. But as Kafka is removing the support for Zookeeper, so are we here in Strimzi. So actually, this is probably my first talk around Strimzi and Kafka, where I now, for the first time, try to focus more on the Zookeeper-less Kafka, which is now pretty much the default way to run Kafka. But next to the Kafka components themselves, We also integrate with a tool called Cruise Control, which is from LinkedIn and allows us to balance the cluster. We have our own HTTP and MQTT bridges. We have some configuration providers, OAuth library. So we have kind of also these smaller projects which make it easier to use Kafka on Kubernetes, not just in the form of running Kafka itself, but kind of adding some additional features. And what we also try to do is it's not all just about running the Kafka servers, but it's also about using them, right? So we have actually also operators that don't just deploy some servers on Kubernetes, but which manage the things inside these servers. So we have management of topics, users, or Kafka Connect connectors using the operator pattern as well. We try to kind of be a nice citizen of the CNCF landscape. So we try to do all of the different tasks which you need to run Kafka, but we also try to do it by, where possible, integrating and utilizing all the other projects from the Kubernetes landscape. We, for example, handle the installation, but yeah, you can pick different installation ways. You can, of course, download the YAML files and do just kubectl apply, but yeah, you can also use the OLM or the operator hub.io to install Strimzi. We have a Helm chart, so you can use Helm as well. For operations, we integrate with various things to handle the cluster balancing, configuration. Obviously, monitoring is something where you are probably monitoring all your applications and you want to have a single view across all of them. So that's why, for example, we try to integrate with projects such as Prometheus or OpenTelemetry to make sure you can use what you are already using for monitoring. And it's similar with the security with the things such as OAuth integration or open policy agent and so on. So we kind of try to fit and be part of this cloud native ecosystem. Okay, let's get into the various components. Let's start with the Kafka brokers. So the Kafka brokers, they are kind of the central part of the Apache Kafka cluster. That's where the clients send the messages to, or they receive the messages from. And the Kafka brokers, that's kind of the part of Kafka which holds the state and which stores the messages. The messages, they are always sent to or from topics, and each topic consists of one or more partitions. So that's kind of how Kafka is sharding the data within the topic, so that each partition can be hosted on different Kafka nodes and can be distributed. And each partition has one or more replicas, and the replicas is basically what makes sure that the data are kept in multiple copies. And if you lose one of the replicas, then there should be always another replica which is ready to take over. And that's how Kafka basically provides high availability and reliability. Typically, you would use Kafka with a block storage, so something like AWS EBS volumes or the similar services on the different cloud providers. But you can use also things such as eSCSI volumes, or Kafka actually works quite well with local persistent volumes as well. So if you want to run Kafka on premise with and you don't have some expensive storage appliance, then local persistent volumes are actually quite a good option as well. But what's relatively new in Kafka, it's G8 in Kafka 3.9, is the support for tiered storage, where we can configure that some of the older messages should be offloaded to some other tier of storage, for example, to object storage, something like Amazon S3, or maybe on-premise, you can use some shared storage such as NFS volumes, and you can kind of offload some of the older messages there and make kind of the brokers a bit smaller, have them store less data on on the block storage, which might make it a bit cheaper to run, a bit easier to scale up or scale down. But for example, object storage has much higher latency than the block storage. So yeah, that's kind of the trade-off where the latency for these offloaded data might be worse, but the running costs, for example, might be much cheaper. So that's one of the options you can now use with Kafka as well. In Strimzi, we have two custom resources to run the Kafka brokers, and that's the Kafka and the Kafka node pool custom resources. They kind of work together hand in hand. The Kafka custom resource, that's what defines the general Kafka properties which apply to the whole cluster. For example, the version of the Kafka software, the listener configuration, some of the security configurations such as authorization, they are all cluster-wide and they are configured in the Kafka custom resource. And then you kind of mix it with one or more of these Kafka node pool resources, which define different groups, different pools of the Kafka nodes, which kind of form the cluster, and they can have different configurations. They are kind of the brokers, which will be then used to send the messages. Here is a quick overview of how the resources might look like, but let me get back to that later in some demo where I actually show you running Kafka cluster. I already mentioned that we are also managing topics and users. Now that's important because if you have the Kafka cluster deployed, you don't want it to be sitting there empty without any data. You want to use it, right? And that's why we have the Kafka topic and the Kafka user resources, which have their own operators, and you can use them to create the topics or the users in the Kafka cluster. For the users, it will automatically generate the credentials for you, whether it's, for example, username and password, or whether it's certificate. And it can also set the correct ACLs for the user and stuff like that, so that the user is allowed only what it should be allowed to do. And the advantage of this is that you can use it to manage the users and the topics in a declarative way using Kubernetes resources. I know not everyone loves YAML, but yeah, so to say, you can use YAML to manage users and topics. But if you kind of look at the other tools usually used in the Kubernetes cluster, then that also means that you can, for example, have your application which is using the Kafka cluster with YAML deployment, Kubernetes deployment as a YAML. Next to it, you can have the YAML of the Kafka user, which this deployment is using to connect to the Kafka cluster, and you can in the same way define also the topic, where it would send or from which it would consume messages, and you add all of that into your Git, and then use some GitOps tools such as Argo or Flux to kind of manage these resources. So that's one of the advantages of these user and topic operators. And again, let's skip this and let's go to a quick demo to actually see the cluster running. So to save some time, I actually already deployed the cluster. So I installed the Strimzi cluster operator. That's kind of the main Strimzi operator. And then I have here some Kafka brokers and Kafka controller nodes deployed. And I have here some of the other tools such as cruise control, the user and topic operator, and Kafka exporter for some additional metrics deployed. But let's have a look at how you can deploy this. And let's actually start with some super basic resource. So if you would want just the most simple Kafka cluster, you can do this with these 30 lines of YAML or something like that. Here I have the Kafka custom resource, which creates a Kafka cluster named my cluster. And it doesn't specify any Kafka version. It just basically uses the default version supported by given Strimzi version. And it just defines a listener. So it will listen on port 9092. We disable any TLS and security. And that's kind of the cluster configuration. And then we just say that in this cluster, in the Kafka node pool resource, we want to have 3 different nodes. And these nodes should have the controller and broker roles. And the only other thing we have to specify is the storage which it will use. So we say that we want it to use 100 gigabytes of storage per broker. So this will be kind of the super simple thing. But what I actually deployed here is a little bit more complicated. It's a bit more, it's not completely production ready. It's running here on my home cluster, but it's a bit more fine-tuned. So again, I have the Kafka custom resource. And I created some listeners here, but this time I actually enabled encryption on these listeners. I enabled the authentication using MTLS, using TLS client certificates. One of these listeners is actually using this type node port, which means that I tell Strimzi that this cluster should be exposed outside of my Kubernetes cluster so that I can access it, for example, here from my laptop. I enable the authorization here. I have some configuration, which is kind of fine-tuned here. I enable metrics. I enable the user and topic operators here, the cruise control, the Kafka exporter. So that's all enabled here. And then again, I have these Kafka node pools where I have one node pool for the controllers. So that's kind of the Kafka nodes which replaced the Zookeeper, which it used in the past. And again, I say that I want 3 of these controllers. I can specify the resources it should have. I can specify the storage. And then I add another node pool, which is for the brokers. So it is the broker role. It is, again, 3 nodes, resources, storage. And then there's just some config map with some detailed metrics configuration. And that's what I applied with kubectl apply. And that's what basically gave me this cluster. It just took a minute or two to kind of pull images, start the pods, and that was all done by the operator. And then next, if I would want to deploy the clients, then as I said, I can basically use these Kafka user resources. So I create this Kafka user, which is called Kafka Test Apps Producer. I say it should use MTLS for authentication. I tell it that it can use authorization and give it some authorization rights. I do the same for the consumer. And then I use the Kafka topic resource to create some test topic here. And I say that it should have 3 partitions with 3 replicas. And then I just create the 2 deployments, one for the producer, one for the consumer. And in the configuration, I just tell it, okay, use the certificates for the authentication from the secrets we created through the Kafka user resource. And then I do the same for the consumer. And that's basically how my application looks like. And with everything, including the security, I can now do kubectl apply on this. It will create the users. It will create the consumers and producers. And just to see that it's working, let's do kubectl logs. Get logs from the consumer, and you can see that it's getting some hello world messages which the producer is sending. So yeah, that's kind of how you can deploy the clients. Paul, do you have something?
Yes, there's a couple questions, but the one that's pretty relevant right now, someone asked, which type of storage volumes are you using here? And regarding your presentation, do you need to use block storage class or something else?
So yeah, so this is using block storage. It's running on my home cluster here right now. So it's local persistent volume, what's being used here. So it's 1 for each broker. If I stop this, you can basically see these are the persistent volume claims which were created by the operator. And they just used, in my case, it's called standard storage class, which was used to provision these volumes, which are basically local persistent volumes in this case. But yeah, any block storage can do, as I said, AWS EBS volumes work pretty well. What you should be careful about is using file storage and things such as NFS, They can be used for the tiered storage, but for the main storage, they usually don't work very well with Kafka.
All right, thanks.
Also, I see that there was another question around requests and limits. So the way Strimzi does it is that when you define the request for memory, then Strimzi kind of tries to decide based on that what might be the best configuration for the Java heap and configure that for you. But you have an option in the custom resource to basically customize this. So if you would want to have something custom, then yeah, you can actually configure some JVM options such as this maximal heap size and minimal heap size and so on. So that can be customized in the custom resource, but by default, Strimzi tries to configure it automatically based on the uh, the the configured resource requests and limits. So let's get back to the slides and let's look at the next component. So that's Kafka Connect, which is kind of an integration framework for integrating Kafka with some other systems. So it's basically a shared runtime where you can deploy container connector plugins and connector instances. And these connectors, they are always either sync connectors or source connectors. Sync connectors means that the connector is reading the data from your Kafka cluster and pushing them into some other system, whereas the source connector is always pulling the data from some other system and sending them as a messages to your Kafka cluster. And you can, of course, write your own connectors for your own systems which you want to integrate with, but the main power of Connect is in the large ecosystem because there's a lot of different connectors that are just available out there, written by different software projects, software authors for things such as databases. There are change data capture connectors such as Debezium. There are various connectors to some storage implementations to, for example, read data from some storage or store them there. There are connectors for other messaging systems, but there are also connectors for things such as Slack, GitHub, so that you can, for example, get your Slack messages into your Kafka cluster where you can do some stream processing or AI on them and stuff like that. So that's kind of what the Connect does with the connectors. And what we do in Strimzi is that yeah, we have these Kafka Connect and Kafka Connector resources, which you can again use to deploy the Connect cluster and use it to manage the resources. So the Connect is used to deploy the Connect cluster, and then the connector resource is what you can use to deploy the different connectors on top of it. So let's have a quick look again at it. So let me first do the kubectl apply because the Connect deployment takes a little bit of time. And while it's being deployed, we can have a look at the YAML. So once again, I follow the same principle. Everything is using some authentication and authorization. So first I have to create this Kafka user, where I give the user the different authorization rights which it needs to run the Connect cluster. And then I actually can create the actual Kafka Connect resource, which, yeah, again, it's a bit similar to the previous resources. You specify number of replicas, you can specify the resources. You have to tell it how to connect to the Kafka cluster, so you can specify the bootstrap address. We specify how to configure the TLS and the authentication. The way we designed Strimzi is that we are, of course, most happy if you use Strimzi for everything. So you run your own Kafka cluster, Connect, MirrorMaker, and so on. But sometimes people just don't want to run their own Kafka brokers because that's the state. They are afraid of it. They think it's too risky or something like that. So you can actually, for example, use some managed service such as Amazon MSK, and then just use the Strimzi Connect deployment to run your own Connect and connectors on your own Kubernetes cluster. So you can kind of this way mix the different components as you wish. And then, yeah, what's also important in this custom resource is, as I said, the Connect platform is really the most powerful part of it is the community of the different connectors. So that's why we have here this build section, which basically tells Strimzi which of these connector plugins, which are in most cases not part of Apache Kafka, but they are kind of their own project, which of these plugins should be downloaded and added to the deployment so that you can actually use them. So in this case, I have this test connector, which I wrote some time ago. It's called Echo Sync, and it just kind of reads the messages from the Kafka cluster and prints them into a log so that you can verify that everything works. But here I basically tell Strimzi, okay, download this connector and build a new container image and push it. In this case, I'm using this address, and then use this for the deployment. And when we go and check the pods, then you can actually see that the Connect cluster is now deployed and running here. And the only thing we need to do next is deploy the connector. So we create the Kafka connector resource. We say what should be the plugin which should be used. And in this case, we say, okay, read the messages from the Kafka test apps topic and yeah, print them to the log at the info level. So let's try that. kubectl apply. And that's deployed. So let's check the logs of the Connect pod. And we can see that it's here reading and printing the hello world messages again. So that's kind of how we deployed Kafka Connect and a connector on top of it, all using YAML in a declarative way. So back to the slides. Let's go through the remaining resources just more quickly without the demos. But we also support Kafka MirrorMaker as a managed application by Strimzi. The MirrorMaker is a tool which you can use to mirror data between different Kafka clusters. So when I talked about the brokers, I talked about the replication and how each Kafka cluster keeps multiple copies, multiple replicas of the data. And that's synchronous, and that can guarantee that the data are stored and that they are available. But this requires the latency to be kind of reasonably small. So normally your Kafka cluster will deploy it within a single region, within a single metropolitan area or something like that. You would not kind of deploy the Kafka cluster with one broker somewhere in the Americas, one in Europe, the third one somewhere in Asia or something like that. But what you can do is you can deploy multiple different Kafka clusters, and you can use the MirrorMaker tool to kind of asynchronously mirror the data between them, copy them from one cluster to another. And because that's asynchronous, it means there are a bit weaker guarantees that the data will be all copied, and there will be always some kind of gap between the last message you have in the source cluster and the last message which was already copied. But it also means that it doesn't care about latency that much. So we can use it to mirror the data from one continent to another. And to do that, we have the MirrorMaker 2 resource to manage that. So again, you can use the custom resource for that. We have some other components as well. As I already mentioned, we have bridges for HTTP and MQTT. We have OAuth authentication authorization library. We have a test container for kind of developing and testing Kafka-based application. We have the configuration providers and things like that. I think there was a question about a schema registry. So Strimzi doesn't directly integrate a schema registry. That has basically two reasons. One of them is that there are many different schema registries, and the question would be, should we write our own to create yet another one? Should we integrate one of the existing, but if one of the existing, which one? So it's not completely easy. Also, some of the popular schema registries, they don't have exactly open source licensing. So maybe you can use them because the license doesn't really limit you, but it might be limiting to what Strimzi can integrate. So we don't directly integrate a schema registry, but you can actually use any schema registry you want. Kafka itself, the brokers, they don't really have any integration with the schema registry. The schema registry is used by the consumers and producers, and in some cases use Kafka as a kind of storage. So if you want schema registry, and yeah, usually if you use Kafka, you have some schema registry, you can basically deploy it as any other application onto your Kubernetes cluster and use it with Strimzi. There are users using the Confluence schema registry with Strimzi, the Apache schema registry with Strimzi, and yeah, I don't remember all the different names. I think there are at least two more which are fairly popular. So you can do it this way. And it's pretty much the same with KSQL, which was one of the other questions. So I think KSQL has a proprietary license from Confluence, so we can't directly integrate it. But as far as I know, you can simply use it with Strimzi as yeah, any other Kafka application, because essentially it's a wrapper around Kafka consumers and producers at the end. So hopefully that answered those two questions. What I want to touch a bit next is that the operators really matter for something like Kafka. I know that sometimes these days there's operator for everything, and sometimes all the operator does is it creates a deployment, and that maybe has a bit questionable value, whether you should write the YAML of some custom resource which creates the YAML of a deployment. But with something like Kafka, it's definitely not as simple, because so if you just look at the core Kafka cluster and the brokers, then that alone is a multi-layered architecture, because you have the craft controllers, or in the older versions, the Zookeeper nodes. Then you have the Kafka brokers, which need to kind of bootstrap through the craft controllers or through Zookeeper. So that's a bunch of internal connections. Then the Kafka brokers, they kind of all talk with each other to replicate the data and keep them in sync. So that's another bunch of internal connections. And you need to kind of configure all of these. Usually you want some security, so you need to have some passwords or TLS certificates distributed between them, make sure they all trust each other and authenticate each other. So that alone can be fairly complex with something like Kafka. Another example of where the operator makes things easier is the custom discovery protocol. So in order for Kafka to be able to scale horizontally and run with tens or hundreds of brokers, it has to make sure that the clients are kind of know which broker is the right one where they should connect to, for example, read from this partition or that partition. And for that, it has its own custom discovery protocol, which needs to be properly configured with the addresses of the brokers. And that's pretty simple as long as you run everything inside your Kubernetes cluster. But when you run it outside the Kubernetes cluster, then it can get very quickly much harder, because you need to use the right addresses of some load balancers, or in the case of the demo, I used here node port. And the operator again kind of configures all of this for you automatically. Similarly, another area, for example, scale up, scale down. This is something that we worked on recently. If you want to scale up or scale down the Kafka cluster, it's not just about creating a new pod or deleting the pod, because if you would scale up and just create the pod will be, the broker will be empty and it will not do anything. So you need to do next kind of a rebalance to shift some of the data from the old brokers to the new broker to actually make it useful part of the cluster. And it's similar with the scale down, where you first need to move the data from the broker, which will be removed to make sure you don't lose them. And only then you can actually delete the pod. And again, this is something what the operator can automate. So I think the operator pattern is really something what gives a lot of value to something like Kafka. And the last demo, which I will try to do quickly, will be around some of these parts. So let's start with something simple. Let's see how does it work when you want to change something in the Kafka cluster. So all I need to do here is I do just kubectl edit Kafka my cluster, and that opens for me the Kafka custom resource. And I can now go here and change some settings. So for example, here in the configuration, let's say I want to save some disk space and maybe some network bandwidth, and I want to use compression for the messages. So all I need to do is to edit the custom resource, and let's do something like compression type dot gzip. So this way we basically say that we want to use compression. I apply the changes to the resource, and when I check the pods, actually nothing is happening with them, because the operator kind of understands all the different configuration options of Kafka and knows that this one can be configured dynamically, and it just connects to the cluster and tells it, okay, I'm now changing this configuration option from no compression to gzip compression. And if I would change some other option, then for example, it would see, okay, this cannot be changed dynamically. I need to do the rolling update of the whole cluster, and it would go and roll the whole cluster. Similarly, what I can show is, let's have a look at the access from outside. So I just create a Kafka user so that I can connect my client to it. And I also check the YAML version of the Kafka resource. And what I have here is the bootstrap address, which it created for the node port listener, which I was showing up on the beginning, if you remember. And I will just copy this, and I will switch to my IntelliJ IDE, which is running locally on my laptop here from which I'm presenting. And I will just paste this address here as the bootstrap servers. And because I'm using node ports, then I just have to disable the hostname verification because it's not supported for node ports. But that's basically it. I use one of the Strimzi configuration providers to automatically get the certificates from the Kafka user resource for me. So all I need to do now is I need to start the application. And we can see that it connects to the cluster. And again, we can see that the hello world messages are flying here. So yeah, that's how easy it is with Strimzi to access it from the outside. Unfortunately, to be honest with all of you, if you want to use it with Minikube or kind locally, especially on macOS, that can be a bit tricky because it's running inside the Docker container. But yeah, with proper Kubernetes clusters, it's pretty simple as this. So that was the last demo. Just for the end, I will quickly run through some of the things we have been working on in the last days and which we plan to work on in 2025. To be honest, really the last 2 or 3 years, most of our time was spent on the zookeeper removal. That's something what's going on for several years in Kafka, but actually just right now, these months, it's finishing. So So the last Kafka version with Zookeeper support was Kafka 3.9. And in terms of Strimzi, it was the Strimzi 045 release. And so that happened in Q4 last year. And now in the Q1 this year, so this month, next month, we are working on support for Kafka 4.0 and on Strimzi 046, which won't support Zookeeper anymore, and it will be Craft only. So this is basically something what Kafka decided to do. I think it's a good change, which will be useful in the long term. But yeah, in Strimzi, we pretty much just have to adopt it to make sure we don't get stuck on some old version. We also worked on some of the features to improve the scaling of the Kafka brokers. So if scaling the Kafka clusters or even auto-scaling the Kafka clusters is something you are interested in, here's a link to my talk, which I had at the KubeCon in Salt Lake City, which was about auto-scaling Kafka brokers. So there you can find more details. And hopefully with the Zookeeper removal finished, we can now focus a bit more on some other features. One of the things we definitely want to do is Strimzi 1.0. So a long time ago, we made probably a bad decision when we decided to wait with 1.0 release for the Zookeeper to be removed. We didn't really know that it would take so many years to get it done. So yeah, that's why I'm saying it was maybe a bad decision, but finally we are there. So yeah, this is something what we will work on to kind of have a new version of the CRDs, which will not support Zookeeper anymore, and then we will do Strimzi 1.0 release, which will be definitely a huge reason to celebrate. We also want to work on better CA abstraction, CA as in certification authority. And what we really want to do is to achieve better integration with the Cert Manager tool and kind of offload the management of the TLS certificates from Strimzi to Cert Manager, but in the future, maybe also to other tools. I know there are some users using tools such as Vault or Benafy or whatever the right pronunciation is. So that's something what we plan to look into. Gateway API support. So you can already use Gateway API with Strimzi today, but it's a bit semi-manual effort. There's a nice blog post which we have on the Strimzi blog about it. But as the Gateway API is maturing and moving towards GA, we want to automate this directly in the operator as well. And kind of one of the stretch goals is to start working on the stretch cluster to be able to run the Kafka cluster across multiple different Kubernetes clusters. Just for this, one warning is, as I talked about the MirrorMaker, I already talked a bit about latency requirements from Kafka. So just being able to run the Kafka cluster across multiple Kubernetes clusters, that will not allow you to run the brokers on different continents or across huge distances. The latency limitations will be still there. So maybe the real value of this will be more in, for example, migrating the Kafka cluster while being used between different Kubernetes clusters and so on. And that's pretty much it. The demo which I did, including some parts which I didn't show, you can find it on this link. It's on it will just redirect you to my GitHub repo where I have all the YAML files and the instructions how to use them. And finally, we are always looking for new contributors, new contributions. It's obviously you can contribute some code and some new features, but you can also contribute documentation. You can help others. You can talk about Strimzi on conferences or on meetups to kind of help us spread the word and so on. So yeah, you can check this out and you can yeah, join us and become a member of the Strimzi community. And that's it. It was quite long, but hopefully it was useful.
Yeah, thanks. Thanks a lot. We had some pretty good questions, so thanks for answering those as well. And then we actually have one more. I don't know if you saw this, but it came from David P. It said, "Can we run producer consumer apps in other namespaces than the one running the Kafka instance?"
So that's good question, and the answer is yes and no. So you can of course run the consumers and producers in different namespaces, but the user and topic operators, they are watching only one namespace, typically the namespace where the Kafka cluster is running. So you have to create them in this namespace, but the actual deployment using them can be running in different namespaces. You can either use, as I used in this demo of the external application, one of the config providers to, for example, get the credentials and the information needed to connect to the cluster. Or we have something called Kafka Access Operator, which allows you to kind of copy the credentials and the addresses of the cluster to different namespace. So the user and topic operator, they work only in a single namespace, but yeah, there are ways how you can get the secrets into different the credentials into different namespaces, and how you can use them there in your consumers and producers.
All right, great. Well, are there any other questions that people have? This is the time. If there's anything else you want to hear from Yaka, but I know there's a lot of content and you did answer a lot of questions throughout. So, um, yeah, well, I don't see anything else coming in. So thank you so much. Really appreciate your time. This was great, super informative. We had a lot of great participation from the audience, which is always great. Yeah, so where can people reach you actually if they want to ask you about Strimzi?
So actually, I'm on the Data on Kubernetes Slack as well, of course. So one of the easiest way to ask something about Strimzi can be there, but uh, probably the main channels for Strimzi are on the CNCF Slack. We have a Strimzi channel, which uh, you can use to ask questions. We have also GitHub discussions, which where a lot of people ask questions. We have also some mailing list, which yeah, that's more announcements, but you can actually use it for asking questions as well. So yeah, any of these channels you can do it, and yeah, we will try to answer any questions or provide help.
Okay, cool. Well, I had one more question come through while you're answering that. Hopefully, yeah, we have a few more minutes. So, how stable is the Strimzi operator with non-ephemeral volumes? Can Strimzi be used stably with, as you mentioned earlier, block storage classes, also in combination with Helm and Argo? And then they said, we have observed in the past that there's a lot of instability at this level, but this has been 1 year. It was 1 year ago.
So we have a lot of production users using Strimzi in production for many years. So I would say yes, it is stable. It can be used in a stable way. It a bit depends on the infrastructure where you are running it. In If you run it in the public clouds, like that's pretty standard high quality infrastructure. If you run it on premise, from my experience, the infrastructure and its performance often differs quite significantly. As for the storage on premise, one thing to be careful from my experience is all kind of software-defined storages, which often kind of share the same network for the storage, which Kafka uses for the replication. And that can often quite easily overwhelm the networking and cause problems with the storage if it's share the same network. So that may be something related. But yeah, in this case, as I mentioned during the talk, like the local persistent volumes might be an option maybe. Uh, Also, as Argo was mentioned, Argo has this feature where it tends to delete the persistent volume claims sometimes. So uh, you have to make sure to disable this purging of the volume claims. The persistent volume claims, they by default don't have their own reference because you don't want them to be deleted by mistake by the Kubernetes garbage collection, because that would cause data loss. So that's why they don't have their own reference, but that sometimes confuse Argo into thinking that it should delete it. So that could be related. Maybe it's not related, but yeah, this is something to be careful. There I'm not honestly personally using Argo, so I don't know the options out of my head, but there are some options how to configure it and how to disable it if this is caused by Argo deleting the PVCs.
Okay, great. All right. Well, thanks for answering that question. Well, we are at time. So again, I'll say it again, thank you. I really appreciate your time. It was a great talk. Of course, we'll make this available on YouTube so people can watch it, wherever they want. But yeah, I appreciate your time. And yeah, hopefully we'll see you at one of the KubeCons in the future.
Yeah, thanks, and thanks a lot for having me here.
Yeah, great. All right. Have a good one. Bye. Bye, everybody.